Yes, ma'am. I'm not saying for wins.
Oh, Grace is planning on winning. She's staying.
I'm planning on
I'm just going. I'm not
winning.
going. My mom literally has blown up my phone and wants me to compete so bad, and I really just don't want to.
Why not?
Because the position I'd be running for, I would have to travel a lot this summer. I would have to go to nationals at the end of June, but I'm taking a college algebra class in Kentucky this year, and you can't miss 2 days, and I would miss a whole week, and I can't do that. Priorities. But if I would have won, they would have paid for all my tuition. But I don't know if I would win, so that's a lot.
That's why I plan on winning.
That's right. I like it. All right, trig functions. Write these the way that I'm writing them, so we'll keep reciprocals next to each other. That little zero with the curl through it, a lot of this you're going to remember, that's the theta, Theta. That's the symbol we use in trig a lot. In algebra, we use X to stand for an unknown. In trig, it is theta to stand for the angle you're talking about. The ones on the left are the normal ones that everybody always knows, sine, cosine, tangent. But there are actually 6 trigonometric functions. Cosecant, secant, cotangent are the other 3. They're easy to use because they're the reciprocal of their neighbor. See how I wrote sine and cosecant on the same line? They're each other's reciprocals. Cosine and secant are each other's reciprocals. So if you can find cosine, just flip it and you know your secant. Okay? Lots of little ways of remembering this. I always was taught Oscar has a heap of apples. Some people did SOHCAHTOA. A kid taught me, oh heck, another hour of algebra. I kind of liked that one. Thought that one was funny for y'all.
I've always liked SOHCAHTOA.
I have a
Yeah.
question.
It always worked for me.
I took the Acupuncture the other day. It's like
It's
and
cool.
we couldn't use calculators on this part, and I didn't know how to figure out what those meant, without using a calculator. Like that. It was it didn't have any numbers or variables. It just had one of those plus one of those equals and the number, and I didn't know what those meant, so I didn't know how to figure it out.
I guess you just missed them. I mean, I don't know what to tell you.
No, I did miss them, I think. I mean, I passed the test, so that's
Good.
good.
Yeah.
But on those questions, I didn't know.
Yeah. There weren't very many of those, were there, though?
No, there was 4.
Yeah.
And that was on the, they have elementary algebra, which tests you to get into college algebra.
Right.
And then they also have the college algebra part.
So you
we'll
can
see if
flip
you
out of
can-
that and get into trig.
Right.
Yeah.
But I didn't pass that one. I just passed.
Yeah, that's all right. All right, so the other ones over there, you could just flip those. Cosecant is the reciprocal of sine, so it would be hypotenuse over opposite. Secant's the reciprocal of cosine, so it would be hypotenuse over adjacent. And then cotangent's the reciprocal of tangent, so it would be adjacent over opposite. Okay, so get your notes started on that, and then we're going to work a few problems using that. Okay, some will wish you would have taken the test after today.
Yeah. Which I'm not concerned about skipping college algebra because Lord knows I'm not smart enough to skip that.
You can do it. You'll be all right in there. All right. First thing I got here, I'm going to draw my axes because these are going to come out of a XY axis. Says here the terminal side of angle theta. So we need to pause and remember something we talked about last week. The initial side is always going to be your positive x-axis. That's your initial side. The terminal side is wherever the line draws to make the other ray of your angle. So it says the terminal side of angle theta in standard position passes through the point 12, 5. So if I go through the point 12, 5, that means from the origin I went right 12 and up 5. So I would be a line that goes through that point. Right 12 and up 5. So this down here would be 12. And then all you do is you just draw a little connector line there to make your right triangle. That would be 5. Now your angle that you're looking from is always going to be from the one at the origin. So this, come on, there you go. That would be angle theta, looking there from the origin. So go ahead and label the stuff from that. 12 is touching it. So it's my adjacent, it's my A. 5 is across from it, so it's my opposite, it's my O. What I'm missing is the hypotenuse. You know how to find the hypotenuse from your geometry days Pythagorean theorem. So we got 5 squared plus 12 squared equals c squared. So that's 25 plus 144 equals c squared, which is 169 equals c squared. Starting off with an easy one, because 169 is a perfect square. Square root of 169 is 13. We'll get into some dilemmas before the period's over today where it's a radical, and that creates a little bit of problem. So now 13 is my hypotenuse. I know that because it's the longest, and the other way I know that is it's always the one opposite the 90-degree angle. See how it's across from that 90-degree angle I just drew. Okay, so the direction said the terminal side of angle theta in standard position passes through that point. Find the values of the 6 trigonometric functions of theta. So that means we got to find sine, cosine, tangent. Then we got to find cosecant, secant, what's that, SEC, and cotangent. All right, so look at, oh, that's ugly. Look at the list that you wrote. Sine is opposite over hypotenuse. So we would just write 5 over 13. That won't reduce, that's it. Cosine is adjacent over hypotenuse. So I would just write 12 over 13. That won't reduce, and that's it. Tangent is opposite over adjacent. That won't reduce, that's it. Then once I get those, all I got to do is take the reciprocal of them for their buddies. Cosecant is the reciprocal of sine, so it would be 13 over 5. Now, Algebra 2's been doing this stuff also, and anytime they say reciprocal, there's some of those boneheads that think it means opposite reciprocal, and I did not say opposite. I just said reciprocal. So the positive or negative stays what it is. You just flip the fraction. Secant would be the reciprocal of cosine, so it would be 13 over 12, stays positive. Cotangent, the reciprocal of tangent, would be 12 over 5, stays positive. Can't see that 5 down there, but you know it's down there. Those are your 6 trigonometric, everybody on say trigonometric 5 times real fast. Those are your 6 trigonometric functions. Capiche? Grace said that at the same time you did, Caitlin. Alright, gonna look at another one where we're gonna worry about positives and negatives. They got what we need on that one? Great. Thanks for your input. Alright. Says terminal side of angle theta in standard position passes through the point 8, negative 6. So I would go over 8 and down 6. So I'd be looking at a line going through that point. You still draw your triangle the same there. It would look like that. So I went over 8 and down 6. So from that angle at the origin, 8, would it be opposite or adjacent? From the angle at the origin, is 8 opposite or adjacent? Very good. There's my adjacent. So 6 would be my, negative 6 would be my opposite. So I need my hypotenuse. So I got a squared plus b squared. I went ahead and just squared them. Is equal to c squared. 36 and 64 is a hundo.
Yeah.
That's a perfect square. So my hypotenuse is 10.
Yeah.
Now, one thing I noticed about these, all of my side links, opposite, adjacent, hypotenuse, are all even numbers. So when I write all these fractions, I'm going to have to reduce them a step, but it's not a big deal. You just take a 2 out. We're going to go sine, cosine, tangent again, and then cosecant, secant, cotangent. All right, sine, opposite over hypotenuse. Like I said, we got to reduce that one. Take 2 out. That'll be negative 3/5. Cosine, adjacent over hypotenuse. Take 2 out. Be 4/5. Tangent is opposite over adjacent. Take 2 out. Negative 3/4. Okay, so we got a couple of them negatives in there. We got a positive one in there. When we take the reciprocals over there, my next 3 answers, the positive or negative stays as it is. So cosecant would be negative 5/3. Secant would be positive 5/4. and cotangent will be negative 4/3.
So why does the negative stay on top?
It could be anywhere as long as it's only there once.
Okay.
You could put it out just out in the middle, or you put it on top, or you put it on bottom, but you can only put it one time. Good question. Alright, now what we're going to see on this next one is the dilemma where we run into some radicals, where we got square roots, because you know that you're not allowed to leave a square root on bottom. So that's what we're going to run into on this next one. Everybody got what we need there? Alright, it says find the 6 trigonometric values of angle theta in standard position if the terminal side, and they give me an equation. The terminal side is 3x minus 2y equals 0. Okay, so on the last problem, I gave you an ordered pair. This time I'm giving you an equation. So we got to get an ordered pair out of that equation. Now that's a line, that's linear. Obviously we're going to be drawing a ray. You know, it's going to be a line. 3x minus 2y equals 0. I could say, remember how when I graph a line, I make an input-output table and I pick my favorite x's and plug them in? That's what you're going to do here. So you just get to pick your favorite x, plug it in, and see what your y is. Now the dilemma a lot of times is, well, like what if I want to pick 4 and then Aaron wants to pick 8? Will we still have the same line? Yes, because that line goes forever. I would just show this part of it and he would show that part of it. We'll still get the same answers. The only thing that it would not be smart to pick right now would be 0. Usually 0 is my go-to point, but if I plug a 0 in, I'm just going to stay there at the origin. So I need to pick 1, 2, 3, 17, 25, some other x. So Grace, pick me an x you want to plug in. 1. So we're going to have 1 comma something. So we got to plug a 1 in for that x. That gets me 3 times 1 is 3. So I got 3 minus 2y equals 0. So now we're solving that for y. So we would subtract 3 from both sides. So negative 2y equals negative 3. Divide by negative 2, and we get a y of 3 halves. Or you could put 1 1/2 if you wanted to. Okay? So what we're looking at here, we would go, and I'm just going to draw my triangle bigger so I got room. We would go right 1 and down 1 1/2. No, we wouldn't. It's a positive 3 halves, stupid. We would go right 1 and up 3 1/2, 3 halves. Sorry, I almost messed us up bad. So, got a line looking like that. To get to that, we went right 1, so there's our adjacent. We went up 3 halves, so there's our opposite. We still got to find the hypotenuse. Okay? So this is where you see we're going to have fractions and radicals and all kinds of stuff. A squared plus b squared equals c squared. So I got 1 squared plus 3 halves squared. When you square that 3 halves, you square the top and the bottom. So that would be 9/4 equals c squared. Oops. Oops. It's even getting worse. Little squares over. Hey, it was a square and then you're a square. Anyway, 1 plus 9/4 is 13/4. So that equals c squared. I do the squared by square rooting. 13 just stays square root of 13. Square root of 4 is 2. So there's your hypotenuse, square root of 13 over 2. Alright, I'm going to work some of this because we're going to have work to do on these. So I'm going to work some of this on the dry erase board and then we'll put our answers up there. Sine is opposites, which is 3 halves, over hypotenuse, which is square root of 13 over 2. Okay, can't leave this. This is way too ugly. First off, you got a fraction within a fraction. Second off, you got a radical on the bottom. Dividing by fraction is the same as multiplying by the reciprocal. So I would set it up, flip that, and multiply. I got a 2 on top and bottom that'll cancel. So I've got 3 over the square root of 13. But I still can't leave a radical on bottom. What can I multiply this whole fraction by that would cancel out a radical on bottom? That's a square root of 13. What would cancel that out? could I multiply this by to make the square root of 13 go away? Yes, thank you, Grace. Square root multiplied by itself, it'll always
Okay.
cancel it out.
Oh,
So
boy.
I got 3 square root of 13 on the top. Then on the bottom, square root of 13 times the square root of 13 is the square root of 169, which is 13. So it cancels out. So for our first answer, our sign, that won't reduce or anything, so that's it. Our sign is 3 square roots of 13 over 13. Now let me do this. Let me go ahead and jump to cosecant while we're there. Because we could come back. Why? It's easy. We could come back to that place and take the reciprocal and not have to do any work. Because sine and cosecant are reciprocals. So flip that, puts the square root on top, which is okay. So cosecant would be square root of 13 over 3. Okay. All right, let's look at cosine now. Cosine is adjacent over hypotenuse, so 1 over, where's my square root of 13 over 2, which means 1 times 2 over square root of 13, which means 2 over the square root of 13. That's going to help me out when I get to secant in a minute. What do I multiply that by to get rid of the square root of 13 on bottom? Square root of 13. So I have 2 square roots of 13 over 13. There's your cosine. Now look back at where I dotted that rectangle. Take the reciprocal there. Square root of 13
There will be an STA huddle for the high school Wednesday morning at 7:30. Thank you.
Now luckily, tangent's going to be a little bit nicer to you. Tangent is opposite, square, which is 3 over 2, over adjacent, and your adjacent is just 1. So that is just 3 over 2. So there's your tangent. And then cotangent is the reciprocal, so 2 over 3. So wasn't anything harder to do when you had a radical involved. You just had a couple more steps to maneuver with. Alright, we've talked about quadrants. We know quadrant 1 is the top right, and then it goes counterclockwise. So if you look up there on that little graph that I've drawn, let me get a new color there. This would be quadrant 1, quadrant 2, quadrant 3, quadrant 4. Okay, we've talked about all that before. You remember all that. Dealing with these trig functions, there are 5 big angles that we use a lot. Starting at the initial side there, back to my highlighter, starting at the initial side, that would be 0 degrees. So your next one there would be 90 degrees. So your next one would be 180. So your next one would be 270. And then back to where you started would be 360. So you've got those 5 degree measures that are your major ones. Those are called quadrantal angles, which is crazy. Quad, Q-U-A-D, rantal, R-A-N-T-A-L, quadrantal angles. So what we're going to look at here, I'm going to give you the measures of all the trig functions for those quadrantal angles, because it just serves as a shortcut, can save you some time on some stuff. Okay, so let's make our little table here. We're going to have angle theta, and we're going to talk about the sine of theta, the cosine of theta, the tangent of theta, the cosecant of theta, the secant of theta, and the cotangent of theta. Okay, and we're going to do those quadrantals that I just named, 0 degrees, 90 degrees, 180 degrees, 270 degrees, and 360 degrees. You'll remember from your time with me in Algebra 2, when we did this stuff, I gave you a copy of the unit circle. All this stuff is coming off of that unit circle that we used in. Alright, so if I'm at 0 degrees, here's the things we're going to fill in our chart. My sine of that angle is 0. My cosine is 1. My tangent is 0. My cosecant is undefined. I'm going to put you in. My secant is 1. And my cotangent is undefined. So all we're doing here is making yourself a little time saver off of the 5 major angles. If you get lucky enough and the question asks about 0 degrees, there you've already written down everything you need to know about 0 degrees. It's just a little bit of a time saver. Okay, 90 degrees. My sine is 1. My cosine is 0. My tangent is undefined. My cosecant is 1. My secant is undefined. And my cotangent is 0. 180 degrees. My sine is 0. My cosine is -1. My tangent is 0. My cosecant is undefined. My secant is -1. And my cotangent is undefined. 270 degrees. We got a sine of -1. Cosine of 0. A tangent that is undefined. A cosecant of -1. A secant that is undefined, and a cotangent of 0. Now, 360 degrees, I haven't filled anything in down there yet, but I already have all the 360 degrees up there. Remember, you start and you finish at the same place, so 360 is the same as 0. So just recopy your 0 answers down there in the 360. Okay, and then have that handy, and we'll answer a question or two using that. Okay, got yours done, ready to look at it. Question says, find the value of the 6 trigonometric functions. So let me write what I'm finding. Sine, cosine, tangent, cosecant, secant, cotangent. Find the value of the 6 trigonometric functions for an angle in standard position with the terminal side through 0, -5. Okay, so 0, -5. If I were to draw that, find that on a graph, I would go over 0 and down 5. So it'd be a point right there, right? Okay, so which quadrantal angle is that? Very good, Grace. If we start here on 0, there's 90, there's 180, so Grace is right. That ends up at 270. So all I got to do now, save myself some time, get my chart, look at 270, and fill all that in. I got a sine of -1, a cosine of 0, a tangent that's undefined, a cosecant that's -1, a secant that's undefined, and a cotangent that's 0. Bam, I didn't even have to do any work. On the tangent, it looks like T-U-N. Okay, remember when we did that 0, -5, let's just use that point that I wrote up there. 0, -5, talking in terms of trig, on the circle there on my XY axis, that first number represents the cosine and the second one represents the sine. Okay, so anytime you have an ordered pair, your first number is your cosine, your second number is your sine. So you can figure out what if you're going to have positives or negatives in all 4 of your quadrants. So let's talk about that. Let's label these quadrants here. If I'm in quadrant 1, I went right, which means my cosine, sine, tangent are all positives, right? Because to get in quadrant 1, you got to go positive. It has to be, everything in quadrant 1 has to be a positive, right? Even their reciprocals, I didn't have room to write them, but cosecant, secant, cotangent would all also have to be positives. Okay, to get to quadrant 2, I go left up. So that means my cosine is negative, right? Cosine would be, let's make a I didn't make this big enough. Let's make a positive list and a negative list. Cosine will be negative. Tangent is sine divided by cosine, so tangent would have to be negative. I went up, so sine would be positive. Okay? Now, their reciprocals, I've been telling you all class period, keep the same sign. So if sine's positive, cosecant's positive. So you could add cosecant up there to the positive list. And then cosine's reciprocal is secant, so secant will be negative and cotangent will be negative. Alright, to get to quadrant 3, you go left and down. So sine and cosine will both be negative. But tangent is sine divided by cosine, so that's negative by negative. So tangent would be positive. Alright, to get to the last one, we go right and down. So cosine's positive, sine's negative. Tangent is a positive divided by negative, so it's negative. And then you can take their reciprocals and get the same thing. Okay, so I'm going to ask you a question or two about that now. Alright, what if I am in, here's how the question reads. What if I'm in quadrant 4 and I want to know if the tangent will be positive or negative? What you got?
Negative.
Okay, Grace says negative. Everybody agree? And you just made a list. Just look at your chart and read it, right? What if I'm in quadrant 2? I want to know what the cosecant will be.
Positive.
Okay, Grace thinks positive. Let's check her out and see. To get to quadrant 2, I go right, or that's left, dumb butt. I go left and up, which means I went negative, positive, which means cosine is negative, sine is positive. Cosecant is a reciprocal of sine. So Grace is correct again. Nice job, GT. Okay, everybody good? Alright, that's what I did the exit question about for first period, so that's what I'll do it about with you. Let's say I'm in quadrant 3, and I want to know if secant is positive or negative. That's what you're going to type to me in your classroom. You got a 50-50 guess. Chance, not a guess, a chance. Send that name again.
Jolie Clement.
I don't think so.
I think she can go on. She passed away yesterday.
What happened?
I think she overdosed.
Okay, it's ready in mine.